In this discussion, we're going to continue our look at while loops and for loops. The core concepts all remain the same. Once you understand how a for loop or a while loop works, then you've nailed it. But what we're going to show you this time is just some concepts that build on to this. In fact, technically, you already know everything I'm going to tell you here. You just may not know you know it, because really what I'm showing you is how to combine tools that you already have with for loops and while loops. One thing we can point out is we can use a loop to accumulate data or to keep a running total, for example. You can run some sort of calculation every time the loop iterates, every cycle through the loop. You could keep a running total, for example. Here, let me show you what I'm talking about. If we had some sort of I don't know, maybe mining days equals 3, like we're running a gold mine operation here, maybe, or maybe this is part of some sort of game functionality where you mine coins. So let's see, for range, and we're going to say, really what we're saying here is we're going to count from 0 to 3 because mining days is equal to 3. We're going to say coins equals coins. And we're going to ask the user how many gold coins they found. And let's see, anytime we get input from the keyboard, we know it's coming in as a string, right? So we probably want to convert this to an integer because we're going to do a mathematical operation with it. And so over the course of 3 days, we found some coins each day, and we want to know what the total number of coins is. So yeah, we'll just ask the user to enter the coins. How many did you find? How many did you find? You'll ask that 3 times, essentially. How many did you find? And then let's say at the end of this, we'll tell the user what they found. We'll say, whoops, I did not want to do. We'll say you found blank coins, right? This is the variable here. You found X number of coins. This is going to be filled in by the program. So let's see. Let's run this. Let's make sure this gives us what we think it does. So enter the number of gold coins found. Let's say 3. You see this loop is repeating, right? First time it asks, the second time it's going to ask. It's going to keep going. Right now, counter is 0. It was. Now counter is 1. And now counter is 2. And this will be the last time it runs. Because remember on range, it doesn't include the 3. It goes up to the 3, but does not include the 3. So this should print back 9. And it does. You found 9 coins. So the point of this, if you're wondering, well, what's the point of this? We already know how to use loops. We learned that last module. Yes, you did. But it's just to emphasize that you can use a loop to accumulate data. You can accumulate it from the keyboard, right? I'm the user. I'm entering this data in, 3, 3, and 3. You can accumulate it from a file when we get to that point. You can accumulate it from a database. You can accumulate it from some other program. It doesn't matter where it's coming from. The point is you can use a loop to each cycle get more of that data. Now, one interesting thing to point out here is look at what I'm really doing here. I'm saying coins is 0 at first, and I'm taking coins, and then I'm adding the value that's in coins to the value we get from the keyboard. And you think, why are you doing that? Well, let's take it off, and let's show you what happens. When we don't add the value of coins to what we're getting from the keyboard, then it's just going to print 3, because that's the last value. When we say coins plus what we get from the keyboard, so let's say the first time this runs, coins is 0. So coins is just equal to 3. But the second time this runs, coins is already equal to 3, right? Because I put 3. And then if we get 3 more from the keyboard, we need to add what the value already was. So one way of avoiding this syntax here There's nothing wrong with this. This reads very good. I mean, it's easy to read for a beginner, and I have no problem if you write it this way. But the book talks about another way of doing the same thing. In fact, let's just take this for a second. Let's take this, copy it and paste it here, and let's comment it out like this. And let's put this in. Plus equals, what does that mean? It means, let me show you, that it prints the exact same thing. What we're doing is, this syntax is the same as this syntax. Plus equals means take whatever was already here and add it to whatever is on the right side. So take whatever's on the left side in this variable, whatever's in this variable, it could be 3, it could be, whatever we put here when we entered this data in, whatever's here, add it to this other side. And let's see, there is a name for this that the book uses. Let me find it real quick for you. There is a table that I wanted to reference here. Let me see, 1 second here. Table 4-1. This is, and 4-2 is called augmented assignment operators. That is the official Python name for this. I couldn't remember what it was called. You want to look at that table. I'm not going to go through every one of these and bore you with that because you can read just as well as I can talk. But there is one also called the one that you use for minus. You can use multiplication and division also. You might just want to take a look at some of those. Plus, I think this one, the plus equals, is one of the most, for me, it's one of the most commonly used out of the whole list. But it is interesting to take a look at that. And just for emphasis here, I'll show you another one. Let's say we can say y equals y minus 2, right? Say y equals 2, then y equals y minus 2. That's the same as saying y minus equals 2. And you can keep going through that list. The same thing applies. We just had an example of the plus equals, where if we use an example from this, we might say that x equals x plus 5, just like we were doing with coins a moment ago. That's the same as x plus equals 5. It's complaining because x doesn't equal anything initially. We need to actually set it equal to something. Maybe up there, it doesn't matter what. So this, if we read through this, x equals 3, x equals 3 plus 5, which is 8, right? Put this equals 8 over here, so we don't forget that. And the same thing is here. This also equals 8, because x is already equal to 3, and it's saying plus equals, so now it's 8. And up here, y equals 2. Y equals 2 minus 2 is, so this is 0. What about now? It's still 0, because y equals 2, and we're saying subtract whatever the value is from the left, using the left side, the value in the left side, which is 2. Subtract 2 from what's on the right side, which is 2. And I'll let you work through on your own the multiplication and the division ones. But the augmented assignment operators, they are interesting and they get handy. After a while, it'll become second nature to you, and you'll just want to, just type it in really quickly and not even think about it. Now, on to the next thing here with loops. We can use loops for input validation. So let's say we have a menu of some kind, like the old-fashioned menus where you said enter 1 or enter 2, enter A, enter a valid number between 1 and 9, and then you display the menu to the user. Let's say, let's get from the user a enter a menu choice between 1 and 9. Okay, that seems good. And remember, let's see, and remember, we have to, yes, we have to convert it to an integer, because when we get it from the keyboard, it's going to be a string. We want to use it as a number, not just as a string. So let's say while menu choice is less than 1, because that's what we said. It needs to be between 1 and 9. So invalid data would be less than 1. And let's see, menu choice greater than 9, right? Again, if it's between, if we need between 1 and 9, then greater than 9 or less than 1 is invalid. This makes sense. So let's say if this is triggered, right? If the above statement is true, if this statement is true, it means it's outside the range, the accepted range that we're willing to accept. Let's say invalid selection. That's what a good menu will do. And then let's say, and we'll just copy and paste this again. So we asked the user initially to enter a menu choice between 1 and 9, and then while they didn't enter the right number, so to speak, while they entered the wrong number, we're going to keep printing this and keep asking them again. And then we'll say maybe print, this is what will happen after we get out of the loop. Now, if we get out of the loop, we know they entered a valid choice, because if they didn't enter a valid choice, then, well, they'd still be in the loop. That's the only way they were able to get out of the loop, was entering a valid choice, right? So let's try this here. Let's put a little space here, some vertical space, never hurt, right? So let's run this now. And let's see, we can enter between 1 and 9. Okay, so let's enter 0. This is invalid selection. That's right. Let's try 11. 10. 800. Now let's try a number that we know is right. We know 5 is right. It says you selected a valid choice of 5. So this is a way that you can use a loop to just keep asking the user over and over. And notice we used a while loop. While is for the best use of while is when we don't know how many times the loop's going to run, because we don't know how many times the user is going to sit there and enter the wrong number. It could be once, it could be twice, or it could be a million times theoretically. And while loops are perfect for this type of testing where we don't know. Remember, for loops tend to run, and you can use these loops in different ways they're not intended to be used, but in their natural use, while is used when we don't know how many times it's going to run. For is used many times in a range of numbers. We know how many times it's going to run. Now, another thing that we can do, and don't worry if you don't get this immediately, I want you to think about it, kind of stick it in the back of your head and think about it. Let's talk about nested loops. This is inevitably confusing for beginning programmers, but this is a good time to go ahead and talk about it. What if we wanted to print the multiplication tables for, 1 to 4, 1 to 5? Let's see. We could say for I in range 1 to 5. Then we could say for j in range 1 to 5. So this is really going to be 1 to 4, right? Because 5, it goes up to 5. It doesn't include 5 in range in Python. So let's print this out. Let's say print. So remember, I is a variable and j is a variable. Those are our two variables, and they're going to run from 1 to 5 eventually. But let's put some text in here. So I times j equals, let me think here, I times j. So that's what we're wanting to print this to the user. We're wanting to print the value of I times the value of j. This is only for the user, right? This means nothing to the computer. The only thing the computer is really doing here is just running this calculation for us, I times j. But the rest of this is just for the user to look at. And then maybe between iterations here, we'll make a print. So I could walk you through this now, but I think the best thing to do here is let's just run this. And I think it's easier to follow this if we have good output like we do below down here. So in this loop run, this is what's called a nested loop. Now, why is it called nested? Because here's one loop, and now we have a loop inside the loop. You see that? This loop, the J loop, let's call this the I loop and this the J loop. The J loop is inside the I loop. We know that because it's indented. And indentions control blocks of code, if statements, while statements, for statements in Python. So inside this I loop, it's really not doing anything except running the for loop, and of course the print statement down here. So let's trace through this, okay? This is called hand tracing. So let's hand trace through this code. On the first iteration, I is 1 because we start at 1. And we don't do anything with I immediately. I is 1 though. Right now, on this first iteration, I is 1. And then J is also 1 because we start J at 1. So this prints right here. The value of I is 1. And then it prints times, and then it says the value of J is 1, and then we print equals, the word equals. That's where this is coming from. I, right, times 1 equals, and then this I times J is 1 on the first iteration. Now when this iteration completes right here, the control goes back up to J again. It does not go to I. Control does not return to I until 1 through 5. J runs all the way 1 through, really it's 1 through 4 inclusive, until J gets to 5. So remember, I was 1, so now J is 2. J is 2 because we just finished this first loop for J where it was 1. Now J is 2. I is still 1 because we haven't returned control back up to the top outer loop yet. I is the outer loop, J is the inner loop, so to speak. So I is 1, now J is 2. And you see how it prints right here. J is 2. Because 1 times 2 is 2. Now what happens next? J is 3. I is still 1. And this will continue. J becomes 3. J becomes 4. And now it won't, once J is 4, it will not re-enter this loop again because the next time would bring it to 5 and it does not include 5. And so this right here is J running 4 times with I equal to 1. At this point, this is concluded. This code executes, and that's what puts the blank line right here. And now I is equal to 2. It took all these times. It took 4 times of this running for J before it would complete, so I could increment from 1 to 2. So if we come back into this again, it starts over. I is now 2, and J is 1. So 2 times 1 is 2 right here. That's where we are in hand tracing this. And then J will become 2 on the second iteration. 2 times 2 is 4. Then J becomes 3, and the product is 6. Then J becomes 4, and the product is 8. So the way I had this set up is each block of output is a repetition of J. And another way of looking at this is the outer loop is over here. 1, see the 1, see the 2s, see the 3s, see the 4s. These are all represented by I in the outer loop. The inner loop, J, is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and so forth. It's 1, 2, 3, 4 every time. So the outer loop is on the left, and the inner loop is right here. I would encourage you to play around with this on your own. Don't be scared of Googling nested loops in Python and finding other examples. There are an infinite number of examples. There's nothing wrong with looking at other people's examples, maybe on YouTube, and I know the book has some different examples as well.